Okay, today we're going to be doing lesson 11-2. This is multiplying and dividing rational expressions. So before we were just simplifying them, today you're going to be multiplying two rational expressions or dividing two rational expressions. And if you understood how to simplify in lesson 11-1, then this lesson shouldn't be difficult for you. It's just a matter of having more steps, and that's it. So example 1 says multiply. We're going to do a few of these. First one is 3 over x times 4 over x squared. So you've done this before. It's a monomial term, a monomial term, monomial term, monomial term. So all you're going to do is multiply across, just like you've always done with multiplying fractions. You can simplify, you can reduce fractions if you can, or you can cross-simplify, cross-reduce. But there's nothing that's going to reduce here, so we just multiply. 3 times 4 is 12. X times x squared is x cubed. And you're done. Okay, now we're going to try one with some binomials. X over x plus 4 times x minus 3 over x minus 2. Okay, what you need to think about here, and we were doing this when we were simplifying, is these binomials are parts together, pieces together. You can't just start canceling x's here, canceling x's here. That doesn't work. You'd have to have an x minus 3 to be able to cancel, which in this case you can't. Now, there's two different ways the answers are going to be represented. Sometimes they're just going to combine them, and you're just going to have something that looks like x times x minus 3 over x plus 4 times x subtracting 2. So if you were taking a multiple choice test, you'd want to go look for that answer. But typically when it's asking you to actually multiply, you're going to take it a step further. Once you've done this and you've simplified anything that is exactly the same, which here we don't have anything, then you multiply it out. So again, you're going to look at just the numerator, just the denominator. So when we multiply out our numerator, we have x times x subtracting 3. You're going to distribute, and you get x squared subtracting 3x. Your denominator, hopefully you all noticed, is two binomials. So you have two options here. You can just FOIL or distribute, or you can use the rectangle. I noticed some of you are getting confused about the rectangle, when the numbers go on the inside and when they go on the outside. So I'm going to just use the rectangle this time to show you. Remember, binomial factors are what are pulled out of the rectangle. They're the product. And then the sum goes on the inside. So when you're multiplying it out, you're finding the sum. So you're given these, the binomials, and you're going to multiply those out to get your sum. So x times x is x squared, x times 4, 4x, x times a negative 2, negative 2x, negative 2 times 4, negative 8. And then remember, these are going to be like terms that you can combine. So now you rewrite it, x squared subtracting 3x over x squared plus 2x subtracting 8. So either of these are actually multiplied, but one is multiplied and just left in product form, and one is multiplied and left in sum form. Typically, this is what you're going to be doing when you're multiplying them out. Okay, so we're going to add or notes about it. You're just going to multiply across and then simplify if needed. So in these first few we didn't have any simplifying to do. Remember, binomials have to be treated different than monomials. So you use parentheses every time, and then you multiply using FOIL or a rectangle. And then you always distribute monomials to binomials. So when you're checking your answers, you're going to notice that the answers in the book for this lesson are in factored form. Which means right here, the easier, the one you came to first. So you just have to be aware of both. Now we're going to try another example. In these examples, we can simplify further. So this is example 2. Multiply 2x plus 1 over 3 and 6x over 4x squared minus 1. So remember, binomials here stay as binomials. Don't start canceling things. So now I have 2x plus 1 over 3 times 6x over 4x squared minus 1. And you have to check every single numerator and denominator to see if anything's factorable. And what you might have noticed is that this is a difference of squares. So that can be factored. You might also have noticed there's a common factor between these two monomials, so you can simplify those. So I'm going to go ahead and simplify those. 3 goes into 3 once, 3 goes into 6 twice. Now I'm going to rewrite my numerator. 2 times 2x plus 1 over, and now I have 1 times this difference of squares over here, so I don't even have to worry about the 1 anymore. And now I'm going to factor my difference of squares. So I should have 2 sets of parentheses, 1 plus, 1 minus. The square root of 4x squared is 2x, and the square root of 1 is 1. And then I check one more time for anything that's going to cancel. And you might have noticed there's a common binomial of 2x plus 1. So my final solution to this is 2 over 2x minus 1. And you can't cancel these 2's because this is a binomial. So just remember, factor when needed to simplify, just like lesson 11:1. And then always remember something like 2x over 2x subtracting 1 don't cancel 2x's. because that's a binomial. Let's try another one of those. So this will be example 2b. Multiply x minus 2 over 8x and a negative 8x minus 16 over x squared minus 4. So I end up with x minus 2 times negative 8 times x plus 2. What I did here is I pulled out a common factor of negative 8. The reason I pulled out a negative is because both terms were negative. So that's going to be my numerator. Now I'm going to multiply and factor the denominator. So I have 8x times, and then hopefully you notice this is a difference of squares. So you're going to set up two sets of parentheses. Square root of x squared is x, and the square root of 4 is 2. And then you have 1 plus, 1 minus. I went ahead and used one fraction bar over both because they're multiplying together anyway. So now I can look quickly for things that will simplify. So I notice matching x minus 2. I notice matching x plus 2. And then 8. So I have a negative 1 over x left over. So again, I factored here by pulling out a common factor of negative 8, factored here, difference of squares. Example 3. Multiply 3x plus 2 over 2x plus 4 and x squared plus 5x plus 6. So when they give you a problem like this, you just need to make this trinomial into a fraction. So everyone should have done that by now. You just put it over 1. And now you're going to do the exact same thing. Look at this binomial, and if it can be factored, factor it, which it can't. Look at this one. If it can be factored, factor it. And then you're going to look at this one. So when we factor 2x plus 4, you should have pulled out a common factor of 2, and you have x plus 2 left over. And then some of you are using the shortcut for the diamond rectangle now. If you're not using the shortcut, set up your diamond and your rectangle. If you are, there's no coefficient here, so we can just look at what adds to be 5 and multiplies to be 6. And you probably noticed it was 2 times 3. 2 times 3 is 6, 2 plus 3 is 5. So x plus 2 times x plus 3. If you don't realize the shortcut, just do your regular diamond rectangle and you'll still have the same factors. So now I'm going to rewrite it. I have 3x plus 2, just from right here, times x plus 2 times x plus 3. That's this trinomial factored. And that's over 2x plus 4 factored, which is 2 times x plus 2. And now I'm going to look for binomials that will cancel or monomials that will cancel. X plus 2 cancels. So I have 3x plus 2 times x plus 3 over 2. If you were taking a multiple choice test and this solution wasn't here, and they had trinomials up here, then you'd want to go ahead and multiply this out using FOIL or the rectangle, and then you should have the right answer. Remember, don't cancel this 2 with anything up there, even if there's another 2, because these are binomials. All right, we're going to try another one. This is example 3b. Multiply 3 over c times c cubed subtracting c. So again, you want to make this a fraction by putting it over 1. And then you're checking each set to see if anything can be factored. And this right here can be factored. So you're going to rewrite it 3 times, and this is a common factor of c. So we have c squared and then you should have minus 1 left over. And this is all over c times 1, which is c. Three c times c squared subtracting 1 over c. Now you're looking for monomial factors that will simplify. This c and c will simplify. So we end up with 3 times c squared subtracting 1. Some of you might notice that's a difference of squares. So there's a chance, if you were taking a multiple choice test, that this could be written as 3 times c plus 1, c minus 1. This is probably the answer in the book. Dividing rational expressions. The really nice thing about dividing rational expressions is you're just going to be using the exact same rules you already know about dividing fractions, and then exactly what we just did with multiplying and with simplifying the other day. So we're going to go through a couple more examples. I'm going to go through them fairly fast because you really should start to look for the patterns of what to factor and how things are factorable. But the rules are very similar to what you already know. So this is really just practice at what you've already learned. So example 4 says to divide a squared plus 7a plus 10 over a minus 6 by a plus 5 over a squared minus 36. So this by, the word by, is actually representing a division symbol there. So as you know, when you go to divide fractions, you're just going to go ahead and take the second fraction and find the reciprocal of that. So I'm going to rewrite this, and when I rewrite it, I end up with a squared plus 7a plus 10 over a minus 6 times, and then I take the reciprocal. So a squared minus 36 over a plus 5. Now you're just going to look for each piece individually factoring. So here we have a trinomial. This one doesn't have anything we can factor. Difference of squares, nothing we can factor. So you've got two things to factor here. First thing was a squared plus 7a plus 10. And again, do a diamond and a rectangle if you need to, but some of you might notice there's a 1 here in front of the a squared. Now that we are getting better at factoring, you should notice that when that 1 is there, you just have to find the diamond part. What multiplies to be 10 adds to be 7. And you should have figured out it was 5 and 2. And so you're just going to end up with an a plus 5 and an a plus 2. And you can check it. A squared plus 2a plus 5a would be 7a plus 10. And then the a squared subtracting 36 is a difference of squares. So you have your 2 parentheses, 1 plus, 1 minus. Square root of a squared is a. Square root of 36 is 6. So now you're just going to rewrite this with multiplying everything. So instead of having an a squared plus 7a plus 10, I'm going to have a plus 5 times a plus 2. Over a minus 6 times a plus 6, a minus 6 over a plus 5. And I'm going to put these two binomials in parentheses also, so that I remember those are binomials, they need to be in parentheses. And now I'm going to look for factors that are exactly the same. So when I go through here and look, I notice I have an a plus 5, a plus 5, and I have an a minus 6 and an a minus 6. Remember, it needs to be numerator to denominator canceling. You can't, if I had another a plus 2 here, these wouldn't cancel and become a 1. They would multiply together and become an a plus 2 squared. So just be careful about that. I have a 1 left at the denominator, so I don't need to do anything with the denominator. So my final answer would be a plus 2 times a plus 6. And again, if you were taking something like a multiple choice test and the answers were written in some form, you would have just multiplied these out and looked for what was the same. Let's try one more of those. Okay, the next one asks to divide (5m plus 10) over 2m minus 20 by 7m plus 14 over 14m minus 20. So again, you're going to look at every single one of them individually after you flip and multiply. So reciprocal and multiply. So first I'm going to rewrite it as a multiplication so that I don't get confused. And if you want, sometimes you can factor as you go. If this is really easy to factor, like here I notice I have no diamonds or rectangles, so I've actually got pretty easy factoring. So I'm just going to go ahead and factor as I convert. So factor and multiply reciprocal at the same time here. So first, 5m plus 10, I have a common factor. My common factor was 5, so I'm going to rewrite that as a 5 times m plus 2 over, and then I look at this binomial right here, and I have a common factor of 2, so I'm going to pull 2 out, and I have m minus 10 left over. Make sure you're keeping the factor you're pulling out. You don't get to drop that factor. Times, and now I need to make sure I flip this. So I'm going to look at the 14m minus 20. That's going to go there. The 7m plus 14 is going to go to the denominator. So 14m minus 20, and if I think about that, the only thing I can think of that's a common factor there is a 2. So I'm going to pull 2 out. Remember, it stays at the top now. And I have 7m minus 10. Now this one is going to go, the numerator is actually going to go to the denominator here. And I have a common factor of 7. And I pull 7 out and I have m plus 2 left over. Now I'm just going to be looking for monomial factors or binomial factors that simplify. So I notice that I have an m plus 2 and an m plus 2. This 7m minus 10 and this m minus 10 aren't the same. So I cannot do anything with that. It's not the same thing. I cannot cancel those out. Even though I have an m minus 10 and an m minus 10, that's 7 there. That coefficient messes it up. I have a 2 and a 2. 5 and 7 don't have any common factors. So now I'm ready to go ahead and put everything together. So I have a 5 times 7m minus 10 over 2 is gone, but I have a 7 here. So this monomial factor should go up front, m minus 10. And this is my answer because nothing else simplifies here. And again, if I needed to, I could multiply it out if there were no matching answers and I was taking multiplication test. So just make sure that you aren't canceling things like this that look similar but aren't exactly the same. Alright, try another one, just to practice. We can call this example C. So this is example 4C. A subtracting 2 over AB divided by A subtracting 2 over A. So again, I'm going to rewrite this as a multiplication problem. So A subtracting 2 over AB stays the same, but then it's times, and now I take my reciprocal, A over A minus 2. Okay, there's a binomial, and there's a binomial. So I need to keep those together. This is a monomial. It's just A times B. There's no addition or subtraction between it. So now I'm sure most of you already noticed A minus 2 and A minus 2 become a 1, and A become a 1. Be really careful with this. I've noticed a few of you making this mistake. This is not just B. There's a 1 left over in your numerator. You need to keep that 1. So this is actually 1 over B. Completely different number than B alone. Example 5 is just more of the same, except now we're talking about where we have to actually make a fraction first. So just being really, really careful with all the steps that you already know. So example 5 asks you to divide x squared plus 3x plus 2 by 4x, over 4x by 5x squared plus 5x. Okay, again, the word by right there is actually representing a division symbol. So what you want to think about is just go ahead and make this over 1. But now you still need to follow the exact same rules that we were following before. So you're still going to need to make sure that you convert or find the reciprocal of the second fraction here and then multiplication. So I'm going to go ahead and rewrite this, and I end up with x squared plus 3x plus 2 over 4x times, and then I need to make sure I take the reciprocal. So 1 moves to the top, 5x squared plus 5x moves to the denominator. Now you're looking at exactly the same thing again. So you should be pretty good at noticing this is a trinomial. It's got that nice easy number in the front. So what multiplies to be 2 and adds to be 3? It was 2 and 1. So we can go rewrite this as x plus 2 times x plus 1. And that's over 4x times 1 over, here I have a common factor. Be really careful with common factors. Your common factor is 5x, and what you need to remember here is that if you pulled a common factor out of a binomial, you should have a binomial left in parentheses. You shouldn't end up with one term in parentheses. So when I divide 5x into 5x squared, I get an x. But then I also need to divide 5x into 5x, and I get 1. You have to have that plus 1. You can't just have an x here, because if I just had an x and I multiplied 5x times x, I'd have 5x squared, and that's it. I need plus 5x at the end. So now if I distributed, I'd have 5x squared plus 5x. So just be really careful with that. Okay, look for things that can cancel. X plus 1's canceled. So your numerator, you have x plus 2. And your denominator, you actually have 4x times 5x. These are monomials being multiplied, so you follow the monomial rules. So I have x plus 2 over, I'm just going to multiply 4 times 5, which is 20. And I'm going to multiply x times x, which is x squared. And I'm not going to simplify anything from there because this is a binomial, this is a monomial. Let's try 2 more of those just to make sure we've got this down. So the next one, 3x cubed over 2 divided by 15x negative 15x to the 5th. Remember, you need to make sure that you go ahead and put this over 1, because then you'll remember to flip, find the reciprocal, and the negative 15x to the 5th is actually going to end up being at the denominator here once we flip and multiply. So I end up with 3x cubed over 2 times 1 over a negative 15x to the 5th. And now you can just look for things that simplify. If you notice here, 3 goes into 3 once, and 3 goes into 15 5 times. X cubed cancels, and I end up with an x squared left over. I take 3 away from the 5 here. So now I'm just going to look. 1 times 1 is 1. There's that 1 again in the numerator. Over a negative, or 2 times a negative 5, which is a negative 10. And then we have x squared. Make sure your fraction goes over that whole thing there. If it didn't, then the x squared would actually belong on the top, the numerator. Alright, one more just to make sure. Y plus 3 over y plus 2 divided by y plus 2. Okay, a lot of you are going to want to just cancel those right now because I see y plus 2 and y plus 2. Have to be careful. Stop and look that for a minute. Think about what you need to do. Good. So you should have put it over 1. And now you have y plus 3 over y plus 2 times 1 over y plus 2. Okay, this is what I was talking about earlier. These are not going to cancel and become a 1. It's not a numerator to a denominator dividing and becoming a 1. This is actually squared. This is y plus 2 times y plus 2. So what you're going to end up with in a problem like this is just your y plus 3 at the top and then your y plus 2 squared, or y plus 2 times y plus 2. Alright, tomorrow we're going to work on this lesson in class, but before we do that, go back to example 4 and we're going to add a few notes to example 4. I'm going to go ahead and add them right here by the divide on the 4b. So just remember, when dividing, reciprocal of second fraction and multiply. Then use multiplication and simplification. Rules you already learned. So this lesson should be fairly easy if you understood Lesson 11.1 pretty well. It's just more of Lesson 11.1, but applying multiplication and division to it and having more terms to deal with. See you tomorrow.